And welcome to a video just on polynomials and more specifically on equality, but I'll just call it polynomials for now. Now, we haven't really come across polynomials yet, but what polynomials are just, well, like x squared plus 3 is a polynomial, and 2x is a polynomial, and x to the power 4 plus 3 cubed, 3x cubed plus 3. That they're all polynomials, and what they are is just anything which is in the form a n x to the n plus a n minus 1 x to the n minus 1 plus so on so plus a to x squared plus a1x plus a0. So basically it's just anything that looks like something like this with x's, powers of x's, etc, 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 anything that looks like that. So just to give you some examples of things that are not polynomials would be like sine x. That's not a polynomial. Other thing might be square root of x and things like that. These are not polynomials, okay? So it has to have the form, all sort of integer powers to the power 4, 3, 2, 1, etc, etc. So that's a polynomial, and the degree of a polynomial is just the highest power. So it's just the highest power in the polynomial. So here, that's x to the power 4, that's the fourth degree, that power. This one, the highest power in this polynomial is 1, and so that's just a degree of 1. This one has got an x squared in it, so it has a degree of 2, and etc. So that should be not too bad. Okay, now next thing that we have to talk about is equating polynomials. And what that means is if we have two polynomials which are equal to each other, so if two polynomials are equal to, so I'll just say polynomial 2 is equal to polynomial 1. If we've got two polynomials equal to each other, then this means that all of the powers coefficients must be equal to each other. And so like if you look at x cubed, then the number that's in front of x cubed must be equal to the number that's in front of x cubed on the other one. So whatever that is, the number in front of that x cubed must be equal to the power of the x cubed over there. I'll do an example of this in a second to make more sense, but you just look at every single coefficient of every single power and they must be equal to each other. I'm just going to straight into some examples just to make it super clear. So I didn't explain that very well. Never mind. I'll go into some examples. So let's just have ax squared plus 2x plus 9 is equal to 3x squared plus bx minus c. So let's have a look at this. Basically we look at each power. On this side, let's just have a look at the x squareds. Okay. On this side, how many x squareds do we have? We have a x squareds. On this side, how many x squareds do we have? We have 3x squareds, and so we get a is equal to 3. Easy. Let's have a look at the x's. How many x's do we have on this side? We've got 2. And on this side, how many have we got? We've got b, and so we have b is equal to 2. And then we've got x to the power 0, which is just our constant here. What's our constant on this side? Is 9. And on this side, what is it? It's negative c. So therefore we have c is equal to negative 9. And so that's just what we're talking about. We look at each of the powers and just equate the coefficients. It's called equating coefficients. Okay, let's have a look at something a bit more interesting. Okay, something like this. So 2a minus 3b x squared plus 3a plus bx plus c equals 7x squared plus 5x plus 7. Now we want to find the values of a, b and c. Okay, so first off let's look at the powers of x squared. Okay, what have we got of x squared? On this side, how many x squareds do we have? Well, we've got 2a minus 3b, lots of x squared. Okay, and there's none others here. On this side, we've got 7. So they must be equal to each other. 2a minus 3b must be equal to 7. Let's have a look at x to the power 1. What have we got? On this side we've got 3a plus b. On this side we have 5 x's over here. And lastly but not leastly, x to the power 0, or just our constant, however you want to say it. We've got c on this side, and we've got 7 on that side, so equals 7. So already we've got c is equal to 7, and what we've got here is two equations. And the two equations in a and b, and so what we need to do to be able to solve this is to use simultaneous equations. Okay, so if we multiply this by 3, we'll get that 3 there, 9 there. So you can use your calculator to do this if you want. That might be a bit easier. So what we get, if now we add these two together, we get 11a equals 22, which means a is equal to 2, and b will be equal to, if I just rearrange these, well, we've got negative 3b is equal to, if I move that, 7 minus 2a, which is equal to 7 minus 4, which is 3. Therefore, b is equal to negative 1. So there we go. A is equal to 2, b is equal to negative 1, c is equal to 7. And that's basically how we do it. Let's just do one or two more examples, but I think you get the idea. Just do maybe one's a little bit more complicated. Maybe express x squared in the form cx plus 2 squared plus a x plus 2 plus d. Okay, so quite often we're asked to express a certain polynomial in a different form. Okay, so let's have a look at it. Now, can you see how that everything's messed up? You can't really see where the x squareds are, etc., etc. So what we need to do is just expand all this out so that we've got, something times x squared plus something times x squared plus something times x plus a constant. We want it to look like that. At the moment, it doesn't look like that. So let's just do that. So I'm going to expand it out. Cx plus 2 squared plus ax plus 2 plus d equals. Let's expand this out. This is c. Let's expand out x plus 2 squared. We'll have x plus x squared, and we'll have 2 times x, 2x times 2, so that's plus 4x plus 4. So that's how we do a perfect square. And I'll just expand this out. Ax plus 2a plus d. So just expanding all that out. And what I'll do is just start collecting it. I'll do one more step. I'll just say no one can yell at me. 4cx plus 4c plus ax plus 2a plus d. Okay, now let's pull everything together. Let's look, where's our x squared? Well, we've just got that x squared there, so that's going to leave that as cx squared there. Where's our x's? How many x's do we have? So that's an x, it's a very messy x. Okay, so x, we've got 4cx here, we've got ax there, and that's it. So there's our x's, and I just like writing it like this. Let's write our constant terms here, so we've just used that and that. What's left over? We've got 4c plus 2a plus d. That's all our constants there. There's no x's involved at all in there. And what we want to say is this is equivalent to x squared, and we want to equate coefficients. Okay, so let's have a look at it. Okay, let's have a look at the x squared terms. X squared terms on this side, c equals x squared times on this side, 1. Done. X terms. X terms, how many do we have on this side? We've got 4c plus a. How many have we got on this side? None. So that needs to be equal to 0. Now we know what c is equal to 0, so we can solve for a here. 4c is 4 plus a equals 0. Therefore, a equals negative 4. And we've got a. Fantastic. And then we've got x to the power 0. Let's have a look at that. What are our constants? We've got 4c plus 2a plus d. There are constants on the left-hand side. What are the constants on the right-hand side? None again. Okay. Let's plug in our known values. 4c is 4. 2a will be negative 8. This is 2 times this negative 4 here. Plus d is equal to 0. which implies that D equals, is there a B in this question? No, there's no B's. Anyway, 4 minus 8 is negative 4, so D must be equal to 4. And so there's your solution for A, B and D. Do one more question just to show you what happens when it cannot be expressed. I'll just another one. Let's just do something like show that A n plus 1 n plus 2 plus B n plus 2 n plus 3 cannot be expressed as n squared. Okay, so let's have a look at this problem here. Show that that cannot be written as this. Okay, and let's just see what happens when we try and do it, and hopefully you'll be able to guess, and let's just see what happens. Okay, so firstly let's expand all that rubbish there. So can I just get equals? I'm not going to write it out again. I'm going to expand it out. So I've got A. Now use FOIL in here. We've got n squared plus 2n plus 1n, so that's plus 3n plus 2 plus B, and then what have we got here? We've got n squared plus 3n plus 2n is plus 5n plus 6. Okay, and I'll just simplify this down. Equals an squared plus 3an plus 2a plus bn squared plus 5bn plus 6b. Okay, and at this stage let's go, okay, we're going to say that's equivalent to n squared. Let's see what happens. Right, let's do a n squared terms. Okay, so our variable this time is n, not x, obviously. Right, what n squareds do we, I should just do this nicely for you. Okay, I won't be naughty. I'll just take out, let's say, n squareds. How many n squareds do I have? I've got a there, and I've got plus b there, and that's it. Let's have a look at how many n's we have. We've got 3a lots there. Take that out. Any others? Plus 5b, and that's it. Plus 2a plus 6b. Okay. Alright, now we're sort of ready. Just to show you maybe a bit better way of setting it out. Let's have a look at the n squared terms. We've got a plus b on the left hand side, and we've got 1 on this side. Great. Let's have a look at the n1 terms. We've got 3a plus 5b on the left hand side, and we've got none on the right hand side. And lastly, our constants, we have 2a plus 6b equals, again, there's none on the right hand side. So I've got these three equations. Now if you put those into your calculator, or do it by hand, let's do it. Let's just solve this, okay? What's the easiest way to do this? Elimination, or let's just do it like this. Okay, so a is equal to 1 minus b. That means you've got 3 times a is 3 minus 3b plus 5b equals 0. Implies, what have you got? 3 plus 2b, so you have 2b equals negative 3. Hopefully I'm right there. Plus 2b negative 3. Yep, so b is equal to, that's a b, negative 3 over 2. Up here we've got a equals 1 minus b, so what's 1 minus 3 over 2? That's 5 over 2. Did I get that right? 1 over 2, yep, 5 over 2. And so we've got our a and our b there, and now let's just plug it into here. For these, all three equations need to make sense. This needs to also make sense, okay? So what's 2 times a? That's 5 over 2 times a is 5. What's 6 slots of b? Well, I'll better just write it down because I'll get confused, you'll get confused. And now 6 times, so that's 3, so that's negative 9. So you've got 5 minus 9, which is negative 4, which you can see is not equal to 0. This should be equal to 0 for all three equations to hold, but this shows you that there's no solutions here. There's no a and b for which all these three equations here hold. And so that means there's no solution. Okay, no A and B for which all those three equations hold. And if that's true, that means it cannot be expressed as n squared. It doesn't work. It doesn't exist. And that's pretty much all there is to it. Enjoy.